I'm making this video for those of you that were not able to watch our first Zoom session. So this is going to be a little bit of a shorter version of what I went over, different concepts you're going to come across this week as well as the upcoming weeks. So for this week, your worksheet, the objective is to find roots of polynomials. And remember, roots are your answers or your x-intercepts. And then there are two types. There are real roots and then complex roots. So here's an example of real roots, such as positive numbers, negative numbers, fractions, or decimals. And then you have complex, which means that there's an imaginary part. So the complex, I forgot a sign here. You have 2 plus or minus 3i, so the plus or minus implies that there are always going to be two complex roots. They always come together. There's always two of them. Okay. Now I'm going to show you how you're going to use that information on your worksheet. The first part of your worksheet that is due next week, I'm doing example number 3. This is the polynomial that's given. The total number of roots is your highest exponent here, which is 5. And all you're going to do is you're going to list the possibilities of real versus imaginary roots. You don't have to do it this way, but I always like to start here. Let me put that in there. So complex means the same thing as imaginary. Okay. So if there are 0 complex roots, that means there has to be a total of 5 real, because your highest exponent is 5. Keeping in mind that your complex or imaginary roots, they always travel in pairs. So if there's 2, then there has to be 3 real. Now because the complex roots always travel in pairs, it is possible that you have 4 of these. And then if you have 4 of these, and you only have 1 of these. Notice that as you move this way, all of these add up to 5. So this is one concept of this week that you're going to use on your worksheet. Let me go back here. The following week, to finish off chapter 8, there's a section on factoring. Remember, factoring means to break something down into a product. The first type you probably already know. It's called the difference. Of 2 squares. So I'm going to give you 2 examples. They're going to be slightly different. So for example, here you have x squared minus 4. Notice that you have the difference, and both of these are perfect squares. Then all you do is you factor it, you break it down into a product. It's going to be the sum of the 2 terms, then times the difference. That is always the pattern for the difference of 2 squares. Remember, if you use the FOIL method and multiply these together to do a check, you should end up with what you started with, x squared minus 4. Here's another possibility, like this. Okay, there are 2 different ways that you can do this, but one way is to first factor out a GCF. Then after you factor out a GCF, you can see that right here, x squared minus 4, that is still the difference of 2 squares. So then you're going to factor it into this. Now this is completely factored. There's your product. And you had to use two forms of factoring, GCF and the difference of two squares to completely factor it. All right, the second type of factoring that you're probably not as familiar with is the sum difference of two cubes. And there is a pattern to this as well. So I'm going to start off with this, x cubed minus 8. Notice that both of these are perfect cubes. And then the pattern is this. You're going to break this down into a binomial, then times a trinomial. Your binomial is going to be these two terms with this sign, x minus 2. To get your trinomial, watch this, watch what you're going to do. You're going to take the first term and square it. You take the second term and square it, that's going to be your last term. To get your middle term, you multiply these two together and take the opposite sign. And now this is the factored form of the difference of these two cubes. Again, if you distribute out the x and the negative 2 to these individual terms of the trinomial, you'd end up with x cubed minus 8. Right now, let's say I have x cubed plus 8. So I still have two cubes, two perfect cubes, but now it's plus. The only thing that is different compared to this is the plus sign goes with the first term. You find these three terms the same way. The only thing that is different is the negative sign is going to be on the middle term. Right? That's the only thing different between the difference of two cubes and the sum of two cubes. One more thing, I want to give you a little more complex problem. So if you have something like this, 27x cubed minus 8, can both of these two terms have to represent perfect cubes? Which they do. So then when I put it in the factored form, these two terms remain the same, as well as the sign for your binomial. And then to get your trinomial, you do the same thing in the previous two problems. You're going to square this first term. So you're going to have 9x squared as your first term. Square this. Then multiply these two together and change the sign, so that's plus 6x. Right? Okay, the last concept that I introduced that we're going to use after chapter 8. In chapter 9, we start trigonometry. And what I'm first going to teach you is how to fill out what's called a unit circle. In the unit circle, it is based upon special right triangles that I think you're familiar with. So one of them is 45, 45, 90, where the sides across from the 45 is 1, 1, and then rad 2. I think you learned the derivation of this in geometry. The second one is a 30, 60, 90. The side across from 30 is 1, from 60 is rad 3, and the hypotenuse is 2. The unit circle, around the unit circle, there are fractions, and the fractions come from these special right triangles. So for example, and they represent specific trig ratios. So the sine of 45, remember sine is opposite over hypotenuse. and I rationalize. Okay. And because these sides are exactly the same, then the cosine of 45, which is also 1 over rad 2, because cosine is adjacent over hypotenuse. So you get the same value as the sine of 45. Okay. Now to finish this off, I'll do the same thing for 30 and 60. So the sine of 30, so again, it's opposite over hypotenuse is 1/2. And the cosine of 30 is adjacent over hypotenuse. It's rad 3 over 2. Okay. Now watch what happens here. I go to 60 degrees. The sine of 60 is opposite over hypotenuse. So I'm going to put it here. And then look at the cosine of 60, adjacent over hypotenuse, that is 1/2. So when we get to the unit circle, this is just a preview, you're going to see that the fractions around them are related to the sine and cosine of these 3 special angles, 45, 30, and 60. And so that's everything that I went over for the first Zoom session.